Imagine standing at the base of a mountain so huge you can't even see the peak. Not because of clouds, but because it's literally over the horizon. A volcano so wide it would swallow the entire state of Arizona. A mountain whose summit actually pokes out above the thin Martian atmosphere. Well, on Mars that place is real. So, get ready to forget everything you thought you knew about mountains. This isn't about Everest. This is about a mountain on a truly planetary scale. On the red, dusty plains of Mars stands a geological wonder that makes everything on Earth look small. It's called Olympus Mons, and it is, no exaggeration, the largest volcano in our solar system. For centuries, long before we sent probes to Mars, astronomers noticed a strange bright spot on the planet they nicknamed Nix Olympica, which is Latin for the snows of Olympus. When NASA's Mariner 9 spacecraft finally arrived in 1971, it got there during a global dust storm. As the dust settled, it turned out this snowy spot wasn't snow at all. It was the peak of a volcano so immense it just boggled the minds of the scientists who first saw it. To really wrap our heads around this giant, we need to completely reset our sense of scale. We're about to take a trip to a place that makes our own planet's toughest peaks look like little hills. This is the story of Olympus Mons. When we think of a tall mountain, we think of Mount Everest. It's the king of our world, standing a dizzying 5.5 miles, 8.8 kilometers above sea level. Now try to picture a mountain nearly 3 times that high. Olympus Mons towers an incredible 13.6 miles or about 22 kilometers above the surrounding Martian plains. If you could just plop it down on Earth, its peak would soar far above where passenger jets cruise, tickling the upper layers of the atmosphere. But its height is only half the story. The truly mind-bending thing about Olympus Mons is its width. The base of the volcano is about 370 miles or 600 kilometers across. That's an area roughly the size of France. A single mountain is as big as a country. Its total volume is about 100 times greater than that of Earth's largest volcano, Mauna Loa in Hawaii. The scale is so massive that if you were standing on Mars anywhere near its base, you couldn't actually see the mountain. Its slopes are so gentle and its footprint is so wide that the peak would be hidden by the curvature of the planet. You wouldn't feel like you were on a mountain at all. You'd just be walking on a gently rising plain, with no idea you were climbing the solar system's most colossal volcano. So what would it actually be like to climb it? Well, forget the icy near-vertical cliffs of Everest. The journey up Olympus Mons would be a totally different game. As a shield volcano, it was built up over eons by countless flows of very runny lava. This created a mountain with an average slope of just 5%. To put that in perspective, many public roads are steeper than that. Your trip would start at its base, which is marked by a dramatic cliff, or escarpment, that in some places rises up to 5 miles, 8 kilometers high. This cliff alone is as tall as some of Earth's greatest mountains. Once you got past that, the climb becomes a long, almost unnoticeable trek across a huge, dusty, volcanic plain. For days you'd walk, and the ground would just slowly, steadily rise. Because of the planet's curve, the summit would always be just out of sight. The sky above would shift from the pale pink of the lower atmosphere to a dark, star-filled void as you climbed, leaving most of the thin Martian air far below you. The atmospheric pressure at the summit is just 2 to 3% of the average pressure at the Martian surface, which is already less than 1% of Earth's. Standing near the peak, you wouldn't feel like you were on a mountain at all. The slope would just stretch out beyond the horizon, only a couple of miles away. It wouldn't feel like you conquered a peak, it would feel like you simply walked to the edge of space. How could a monster like this even form? The answer is deep inside Mars, and it comes down to what makes it so different from Earth. Here on our planet, the crust is broken into massive tectonic plates that are always shifting and sliding around. Volcanoes, like the ones that form the Hawaiian Islands, are created by hotspots in the mantle. Plumes of magma punching through the crust. But because the Pacific plate is always moving, the hotspot creates a whole chain of smaller islands instead of one giant volcano. Mars is a different story. It's a world without plate tectonics. Its crust is basically one solid stationary piece. For billions of years, a massive hotspot of magma under a region called Tharsis has been pumping out lava. And because the crust doesn't move, all that lava just piled up in the exact same spot layer after layer for an unimaginable amount of time. Combine that with Mars's weaker gravity, only about 38% of Earth's, and you have the perfect recipe for a supervolcano. The lower gravity lets volcanic mountains grow much, much taller before they collapse under their own weight. So, while Earth's geology is constantly recycling and spreading things out, the stillness of Mars allowed Olympus Mons to just grow and grow and grow. After your long, nearly flat journey, you'd finally reach the summit, and it's a destination unlike any other. You wouldn't find a single sharp peak, but a vast, complex depression called a caldera. The caldera of Olympus Mons is a staggering 53 miles or 85 kilometers wide. You could comfortably fit the entire Baltimore-Washington metro area inside it. This enormous feature wasn't made by one giant explosion, but by the ground collapsing after magma chambers below emptied out over countless eruptions. What's left is a series of 6 overlapping pits, creating a fractured landscape up to 2 miles deep. Standing on the edge of this caldera would be like looking out over a canyon on a continental scale. From this high up, you'd see thin Martian dust storms swirling far below. The other giant volcanoes of the Tharsis region, Martian Mons, Pavonis Mons, and Ascraeus Mons, would just be distant bumps on the horizon. It's now thought that the combined weight of these 4 massive volcanoes was so great that it may have actually caused the entire crust and mantle of Mars to shift, tilting the planet by about 20 degrees some 3 billion years ago. For all its power, Olympus Mons seems to be sleeping. The most recent big eruptions are thought to have happened around 25 million years ago. In human terms, that's forever. But in geological time, it's just the blink of an eye. For a long time, scientists figured it was extinct, but recently the evidence has started to point in another direction. Some of the lava flows on its sides look surprisingly young, with some studies suggesting they could be as recent as 2 million years old. This, along with seismic rumblings detected by Martian landers, has led some scientists to believe that Olympus Mons isn't dead, but just dormant. They think a plume of magma might still exist deep underground, meaning this giant could, one day, erupt again. Now, an eruption isn't likely anytime soon. These things happen on geological time, but the mere possibility that the solar system's largest volcano is still active is a thrilling idea for science. It suggests that Mars might be a more dynamic world than we once thought. Olympus Mons is more than just a big mountain, it's a time capsule. Its endless layers of lava hold a physical record of Mars's long and dramatic history. Studying its geology gives us clues about how the Martian mantle evolved, the history of its climate, and the forces that have shaped the red planet for billions of years. And perhaps most intriguing is what it could mean for the search for life. The immense heat from all this volcanic activity could have melted subsurface ice, creating pockets of liquid water shielded from the harsh surface. These warm, wet environments could have been potential havens for microbial life. Understanding this sleeping giant is also key for the future of human exploration. Sure, active volcanism could be a risk for future Martian colonies, but it could also be a source of geothermal energy, a critical resource for any permanent settlement. Olympus Mons isn't just a relic of the past, it's a key to understanding Mars's present and a potential resource for its future. From a base wider than entire countries to a summit that scrapes the edge of space, Olympus Mons is a monument to planetary forces we can barely wrap our heads around. It's what happens when a world doesn't move, and a single fountain of fire is allowed to build a mountain to the heavens over eons. It challenges our very idea of a mountain and reminds us that the worlds beyond our own play by a completely different set of rules, creating landscapes that are both alien and awe-inspiring. As we continue to explore the red planet, this silent, sleeping giant waits, holding the secrets of a volcanic past and, just maybe, an active future. If your sense of scale has been permanently broken, consider subscribing and hitting that like button to join us on more journeys to the most extreme places in our solar system. The cosmos is full of wonders, and we've only just started exploring.